Algebra 2. This is 4.3, Chapter 4, Section 3, Matrix Multiplication. And let's just cover in this first video the bare basics of it. So how do you do it, and can you do it or can't you do it? Just kind of that whole discussion there. So first of all, matrix multiplication. This is going to seem really weird at first. We're going to take our first row off the first matrix, and we're going to take our first column. Let me come to the first column off my second matrix. I'm going to take this and I'm going to flip it sideways so it lines up. That my first element, my second element, and my third element. Now what I'm going to do is I'm going to multiply. So let me grab a pen here, and I'm going to take these first two elements here and I'm going to multiply them. So 2 times 6, and then I'm going to add that to the second two elements being multiplied together. So that's 3 times 2. And I'm going to add that to the last set of elements here, this 4 times 5. And whenever I do that, I end up with 12 plus 6 plus 20. And the final answer on that, 12 plus 6, would be 18, 28, 38. The answer would be 38. So in my new matrix, I have an element here that would be 38 that is taken from this first row and this first column. Okay, so that's the very first thing I need to do. This is a really long process, by the way. So another one of those long processes, not hard, but kind of weird at first and kind of complicated. Then I'm going to take my first row times the second column. First row, second column. And I'm going to flip that around. Okay. So let's not get confused here. This is the first row times first column. This is now, oops, I don't want to do that. This is now my first row times my second column. First row times first column. First row times first column gives me my first row, first column element. Now I'm going to do my second one. So I am going to grab my first elements here. So that's 2 times 1 is 2. Grab my second elements here. 3 times 8 is 24. And grab my third elements here. 4 times 7 is 28. And when I add that all together, 2 plus 24 is 26. 26 and 28 would be 54. So my first row, second column is going to be 54. Now I'm going to keep going. Now I need my second row. And I'm going to have to do the same stuff with my second row. Second row, first column. Oops, grab the wrong thing again. Probably shouldn't have put that so close. Flop that over here. So I've got my first elements here. So that's 4 times 6 is 24. I'm going to add that to 2 times 5 is 10. And I'm going to add that to 5 times 6 is 30. So 24 plus 10 plus 30, that's 24 plus 40. So that would be 64. And so that is going to be, oops, wrong. Let me move that over. So that should be my 64 here. No, just a little bit. Okay. And this was my second row times my first column. And this is my second row, first column answer. Okay. So section that off. And then I've got my last one here, and I'll just squeeze it up here. Just going to take big sections of paper. Second row, second column. Knock that on over here and line it up. So I have my first element. Again, this is my second row, second column. So 4 times 1 is 4. 5 times 8 is 40, and we're just adding up all of these multiplications. 6 times 7 is 42. So that's going to be 44 plus 42, which is 86. And so 86 is my second row, second column, 86. And this answer right here is the final answer to the problem. When we multiply those matrices together, we get the 83, the 54, which just comes from down here, right? 54, the 64, and this 86. So that seemed pretty darn confusing, right? So why don't we try this again? Can you multiply all matrices by each other? So let's look at this matrix. So again, matrix multiplication. You are going to take your first row times your first column, and you should be able to match them up. Oops, mine's just a little bit off on size. How about that? That work a little bit better? Maybe a little bit bigger. Okay. Does it line up? Element for element. It lines up element from element, so this is going to work on this one. So I'm going to go through and I'm going to multiply. This is my, grab red for this one, my first row times my first column, right? So 5 times 2 is 10. 4 times 3 is 12. 4 times 1 is 4. 5 times 2 is 10. And 6 times 1 is 6. Then I just add them all up. So 10 plus 12 is 22. 26, 36, 36. This becomes a 42, if I added correctly. So let me grab my matrix. This will be where I put my answer. That was my first row times my first column. So my first row, first column answer is the 42. Okay, so then I'm going to do first row times second column. So I need to extend my page here a little bit. So I need my first row and my second column. And again, this is not going to be big enough, so I need to make it a little bit bigger. And it lines up one element for one element, so it does work. And let's do this one in a different color. So let's go grab green. So this is my first row times my second column. So 2 times 2 would be 4. 3 times 3 would be 9. 4 times 2 is 8. 5 times 2 is 10. And 3 times 1 is 3. Then you add all of those products up. And I'm getting tired, so I'm going to grab a calculator here. So 4 plus 9 plus 8 plus 10 plus 3. Those people who know me, when I get tired, I tend to not do my math, my basic algebra skills correctly. So my first row, second column is going to be a 34. First row, second column. First row, second column, that would be here. So that would be my 34. Right. So then we're going to grab my second row. So let's grab this second row, pull this off of here, and we're going to move that on down here, down to the bottom of my page. We'll keep going. That's my second row, right? And this is my first column. I need that one. We'll move it on down here. And I need to tip it over so it lines up. Make this one a little bit bigger. That can line up pretty good. A little bit bigger. There we go. That's pretty good for lining up. So it's my second row now. So grab blue. This is my second row and my first column, right? Second row, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And first column, 5, 4, 1, 2, 6. 5, 4, 1, 2, 6. Okay, so 5 times 1 is 5. 4 times 2 is 8. 1 times 3 is 3. 4 times 2 is 8. And 5 times 6 is 30. And then we can just add these up. Again, a little tired here, so 5 plus 8 plus 3 plus 8 plus 30. And we end up with this being 54. So this is my second row, first column, and this is a 54. So back up and grab my last set of numbers. So that's my second row with my second column. So move this down so I can get to it. Second row, second column, and we flip it over, put this underneath it. What did we ever do without smartboards so that we could do this nice technology here? And let's grab a fourth color. And so this is my second row, second column. So 1 times 2 is 2, 3 times 2 is 6, 2 times 3 is 6, 2 times 4 is 8, and 3 times 5 is 15. Then just add them all up. And you end up with 2 plus 6 plus 6 plus 8 plus 15, and you get 37. So my second row, second column, answer is going to be 37. And this would be my resultant matrix when I multiply those two matrices together. So this is a 2 by 5. This was a 5 by 2. And we ended up with a 2 by 2. And you're going to start seeing this pattern really quickly. Notice the 5s are the same. The number of columns has to be the same number of rows in the second one. So the numbers here, these inside numbers, 5 and 5, have to be the same. Let's look back at this one. This was a 2 by 3. This was a 3 by 2. This number here, this 3 and this 3, had to be the same, because when we matched them up, we had to have the same number of elements. And our answer was a 2 by 2. Notice that's our outside numbers, gives us what our resultant matrix is going to be, and the inside numbers are telling us whether we can multiply them. Inside numbers, 5 and 5, we can multiply them. Outside numbers, 2 and 2, that's what our resultant matrix size is. So let's look at this one. Can we multiply them? This is a 2 by 5. This is a 5 by 3. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3. 1, 2, 3, 4, 5. Okay. So the inside numbers 5 and 5 have to be the same. That way when I pull the elements off, this one and this one, will they match up? Well, if they were all the same size, they sure as heck would, right? So the inside numbers are the same, so we can multiply them. Your answer, in this case, your answer is going to be a 2 by 3. So your answer will be a 2 by 3 matrix. So what about this one? This is a 3 by 1, 2, 3, 4, 5. This is a 3 by 5. And this is a 1, 2, 3, 4, 5, a 5 by 1, 2, 3. So you look at the inside numbers, 5 and 5. Can you multiply them? Yes, they match up. What's your resultant matrix? It's going to be a 3 by 3. Your resultant matrix will end up being a 3 by 3. What about this one? 1, 2, 3, 4, 5, 6. This is a 2 by 6. 1, 2, 3, 4, 5. This is a 5 by 3. This is a 6. This is a 5. Can't multiply. You cannot multiply these items. Okay, so then the question is, what about commutative? If you can multiply one way, can you multiply the other? Well, let's go back and look at this. If this is a 5 by 3 and this is a 2 by 5, right, we can multiply them when you multiply, let's call this A and this B. So yes, you can multiply A by AB, and when you multiply AB, you get a 2 by 3. What if I wanted to take BA? Well, let's look at that. B is a 5 by 3, and A is a 2 by 5. Are the inside numbers the same? No. Which means you cannot take B times A. You can only take A times B. So now we don't have commutative property working anymore. So same thing with this one. If this was a 3 by 5 and this was like C and this is D, CD would end up with a 3 by 3 for its answer. What would happen if we took DC? Well, D is a 5 by 3, and C is a 3 by 5. Can you multiply them? Yes, you can multiply them, but the resultant will end up being a 5 by 5. So you're going to get different answers. Commutative property is not going to get you the same answer anymore when we talk about matrix multiplication.